analyze a graph, we look for directions. When we analyze parts of functions, we're looking for the direction that it goes. So if a graph is going up, it is increasing. That would be a vocabulary word. It would be increasing. If the graph is going down, we would say decreasing. So if the graph is going up, it's increasing. Something is increasing.
Neither.
If it is going down, we would say that it is decreasing. And if it was flat, we would say that it was staying the same. It's not moving. It's still, right? There are some other vocabulary words that we could use for flat. But if it's going up, it's increasing. If it's going down, it's decreasing. And if it's flat, we say it's staying the same. So we then talk about what it looks like. So yes, I understand that going up, I understand that direction. But there are two ways that a graph could go up. It could go in a linear fashion. What does linear mean?
In a straight line.
In a line or straight. And what would non-linear mean? Curved. It could mean wavy. It could mean a variety of different. Linear. A straight line that is going up, or a straight line that is going down, decreasing or increasing, doesn't matter which way. If it is a line, it's constantly increasing. Because a line has a slope, meaning it is always going up and over at the same rate. If it is linear. If it is linear, it is constantly increasing. If it is linear, it is constantly increasing.
Non-constantly for non-linear?
It is constantly moving. It is constantly whatever. Maybe it's constantly increasing. Maybe it's constantly decreasing. But linear, if it makes a line, it is constantly. It is moving at a specific rate of change. If it is non-linear, if it's curved, it's not constant, right? It might be quickly. It might be just increasing or decreasing. If it has the word constantly with it, that means it's a line. If the word constantly is not with the description, it's nonlinear. It's not moving at a constant speed. Q-U-I-C-K-L-Y. It might be rapidly. It might be slowly. It might be erratically, right? It's just not a constant thing. It has to say constantly if it is linear. Patrick, will you put the computer or the calculator down and focus, please? All right, so I'm going to zoom in here just so that we can really see the graph. We're going to describe parts of this function. So between x is 0 and x is 4. So 0 to 4 right here. So that means in this little section, which direction is it going? Up, down, or flat? It's going up, so it's going to be increasing, but is it constant or not constant? It's not constant, so I would just say that it is increasing. And maybe it's increasing speed, right? Or it's increasing the distance. But it's not constant. And the reason I know it's not constant is because it is not linear. If I look at the next section that says between x equals 4 and x equals 8, so from here to here, which direction is it going? It's going down, so it's decreasing. Is it linear or nonlinear? Nonlinear, right? It's a curve. So it's not constant. So we could say decreasing quickly. It's not decreasing constantly. It goes down pretty quickly. Do you agree? And then when it starts to curve a little bit, it's starting to flatten out. It might be slowing down. But because it is non-linear, it is not constant. There is a variance to the graph. So now we're going to explain what is happening. We're going to use some words to describe these 5 graphs. We have A, B, C, and D. So we're going to talk about the distance versus the time on each one of these graphs, right? And we're going to describe it using our words. So graph A, is it going up or down or flat? Up, down, or flat? Graph A, up, down, or flat? Up. Linear or nonlinear?
Linear.
Linear. So I'm going to say that it is
Linear.
constantly, and then the more time, the more distance. So constantly what?
Growing.
Constantly growing, constantly moving away, constantly driving, right? Like there's lots of different descriptors that I could use for time and distance. Looking at B, is B going up, down, or flat?
Down.
Down. Linear or nonlinear?
Non-linear.
Linear.
What?
Constant. So constantly decreasing. Because it's linear. This, as time increases, the distance decreases, right? It is constantly decreasing because there is a slope to that line. Graph C, up, down, flat. Flat. What does flat mean?
It's not moving.
So how could you describe distance over time?
Staying still.
Yeah. It's staying still. As time increases, its distance does nothing, right? It stays the same.
Constantly increasing.
Letter D, increasing or decreasing? It's increasing. Linear or nonlinear? Nonlinear. So I could say it's increasing, but how is it increasing? Is it going up really fast? Or is it
It's a roller coaster.
Increasing.
at the beginning what's happening? Is it fast or slow? And then what happens? It gets fast. So we could say the or maybe let's say starts slowly.
But can there be like multiple different answers?
Uh-huh. It starts slowly, but
Then zoom.
then increases quickly.
Yeah.
It starts slowly, right? But then as time increases, it goes up fast. It's increasing. It just starts slow and then speeds up. It's not linear. What about E? Up, down, or flat? It's up. But what's the difference?
It goes zoom and then flatten out.
So it starts quickly, then slows down, starts up quickly, or starts increasing, or starts going quickly, and then slows down. Down has an N on the end. So it's one of those things that we've talked about that can have multiple correct answers, but there are incorrect answers. You can be wrong, even though there's more than one right answer. All right, so let's match. Next page. Match the distance and time graph with the correct description. I'm going to read them, and there are A, B, and C down here, and you're going to pick which one is A, B, and C. Ready? Number 1, letter A. Kaylee got on the bus at her house. The bus made 2 more stops before it arrived at school. Letter A. Which graph matches the situation? Kaylee got on the bus at her house. The bus made 2 more stops before it arrived at school. Olivia, which one? Why do you say the second one?
Because it stopped twice for like the same amount of time.
Okay, so if I'm Kaylee and I get on the bus, I go away from my house. So I'm going up at a constant speed, right? Then it stops, so it goes flat. Then it drives to the next school bus stop. Then it stops again and goes flat. And then it goes to school. Perfect. A. Kaylee is A. B. Brennan and his dad leave for school in his dad's car. They stopped at the train tracks for several minutes before they were able to continue to school. Again, Brennan and his dad left for school in his dad's car. They stopped at the train tracks for several minutes before they were able to continue to school. Which one represents Brennan and his dad, Evan? The first one, why? Because it stops. So we go up, we drive away, and then there's a pretty long stop, right? Because we have to wait for that train to go, and then we continue. Let's check C. Cameron left for school with his mom, but remembered he left his English project at home. She took him back home to get his project, and then they headed to school without any stops. So here it is. They leave, they turn around and go back. He goes inside, so it's a little bit of a lull to get the project, and then they go to school. Do you see how you match the situation? So now we're going to create the graph. I have 5 scenarios, and we're going to draw our graph over here. Adam left his friend Brody's house and started walking home. Up, down, or flat? It's going to be up. Do you think it's going to be linear or non-linear? Probably pretty linear. Is it going to go up really fast? No, he's walking. Like this?
Yeah.
So there's A. Adam realized he left his phone at Brody's, so he turned around to get it. Now what's going to happen?
You're gonna go down.
He's going to go down because he's not going back. He's not going to home. He's going back to where he started. B. Adam left Brody's a second time and started to walk home. Up, down, or flat? Up. Maybe a little bit higher because he thinks he's going to be late now. See? Adam stopped halfway to talk to a friend that he passed. Up, down, or flat? Then he quickly ran home to make it for dinner.
Yeah, it's like almost an idea.
Like this? Because quickly is one of those that we are not linear.
Is that good?
Or could be non-linear.
This is
Right?
fun. I do this for a living.
I don't have enough imagination for this.
Let's do the next one. Vanessa's distance from house. 4 sections. Vanessa left her house at a jogging pace. Up, down, or flat?
Like
Up.
90 degrees.
Linear or non-linear? What word? Steady. What does steady tell us? Linear or non-linear?
Non-linear.
Linear.
Linear. Steady means constant, correct?
Yeah, it's a straight line.
So it's going to be straight, but she's running, right? So it's a little more up than walking, right? More vertical than walking. It's not straight up, though. Part B, she increased her speed, but at about halfway got a leg cramp. What happens when she increases her speed?
She gets a leg cramp.
Well, what does it look like to increase your speed?
It goes
It's going to curve up just a little bit more, right?
Oh, I thought it curved down.
Because she's increasing her speed, but it's not linear. But what happens when she gets a leg cramp? Part C.
It goes down.
She stops. So what does that look like?
Flat.
Flat. Then she decided to turn around and walk back home at a much slower pace. What's that going to look like?
Yeah, totally.
It's going to decrease. Is it going to be a like
Straight down.
sharp
Yeah.
decrease?
No, because it's not fast.
It's slower. So what's going to happen?
It's gonna be really cramped.
It's going to be like this, right?
But can you go out of the grass?
Yeah.
Oh, you're smart.
Right? It's not going to go because that would be a fast pace. This is a slower pace, right?
Justin starts walking.
Now you're going to go backwards. You're going to write the story that goes with the graph.
Justin gets a phone call.
You're going to write the story about Justin that matches the graph. So part A is increasing, goes up, but it's constant, right? So we're going to say walks to
Justin gets off phone.
school. B, up, down, or flat?
Flat.
Flat. So maybe he stops
Check his phone.
to
Then Justin gets a phone call.
tie his shoe.
Oh my god, this
And then letter C, it's non-linear, so it's not constant, but it's going up. So what could you say? Like he realizes he's late, so he runs so he's not late.